Mr. Minnick helping my students with if statements worksheet number 4. Here we have some if statements, some if-else statements, and let's trace them from top down like the computer does. Num equals 5. Keep track of num as a variable. It's 5. The answer is 0, so put a little 0 there. And now we get to the if statement. If you remember the percent symbol, you better remember, the percent symbol means modulus, or you can think of it as the remainder operator. So num, which is 5, is being divided by 2, and whatever the remainder of that is what that expression simplifies to. Well, let's take 5 divided by 2. 2 times 2 is 4. We get a remainder of 1. Now, you probably could do that in your head. The remainder is 1. 5 divided by 2 yields a 1 remainder. Anyway, all of this simplifies to the 1 that we just found. 1 is indeed equal to 1, so this is true. And because that's all that we have in this if control expression, the true tells us that this executes, the computer does that, and it ignores anything else in the if statement, which would mean the else gets ignored. And answer should be crossed out and turned into a 1 there, the way I like worksheets to be done. The final value, therefore, is 1. It should be circled, and that 5 is circled, and you circled this, of course. And number 2, num starts out as 11, answer starts out as 0. I know that you can't really see it in the video there too well, but that's that. Okay, according to order of operations, we have to do these percent symbol mod operators before the ors and all that. So let's just work from left to right. What's the remainder of 11 divided by 2? 1. And is 1 equal to 0? False. Hey, what's 11 divided by 3? What's the remainder of that, rather? I can do that in my head. It's 2. 11 divided by 3 has a remainder of 2. 2 is not equal to 0, so this is false. And 11 divided by 5 has a remainder of 1. That's not equal to 0, so that's false. And finally, 11 divided by 7 yields a remainder of 4, and 4 is not equal to 0. So what the heck? I have falses on all of these parts with ors. When you have a false, or false, or false, or false, the whole thing is one big giant false. So we do not do this line of code that's indented here, answer equals 1. Because that's an else, we always execute whatever is in the else because there's nothing there to block us. There's no possibility of getting a false. So answer is equal to 2. Now what did that just tell us? All this crazy remainder stuff. Pretty much because 2, 3, 5, and 7 are prime numbers and therefore possible divisors of the number 11, because they do not divide evenly into 11 and therefore give a remainder of 0, we know that 11 has no factors. That's just a way, so you can't say that 11 has factors other than 11 times 1, which doesn't really count, and therefore 11 is prime. This algorithm, this if statement, detected whether the number num was 11. If num were 12, something in this would have been true, and the answer, instead of being 2 here, it would have been equal to 1. Okay, number 3, num is 5, answer is 0, and we, look at this mess, this one big if statement. You always do ands before ors, so we got to do this and before the or and the or and the or. Okay, num is 5. What's the remainder of 5 divided by 2? Okay, 1. Is 1 not equal to 0? That's true. Now we move over here. The remainder of 5 divided by 3 is 2. Is 2 not equal to 0? True. 5 divided by 5, that would yield a remainder of 1, and 1 is not equal to 0. So that's true. And now we check, is num directly, there's no percent symbol, there's no mod. Is num, is 5 equal to 2? False. Is 5 equal to 3? False. Is 5 equal to 5? True. So now what do we have? If I rewrite all this mess, I have a true ANDed with a true, ANDed with another true, ORed with that false, and there are no other parentheses involved. ORed with another false, and then finally ORed with another true. Well, how? Well, we have to do the stuff around the ands first. True and true simplifies to a true. That true ANDed with that true simplifies all of this to a true. That true ORed with that false simplifies all of this to a true. And that true ORed with that false simplifies this with a true. And I'm left with true or true, which the final answer is true. So that means all of this is true, and therefore these two should be circled. And therefore answer equals 1. The 1 plugs in there for 0. And this is what prints out on the screen. We're taking the number 5 and we're turning it into a string with the str function. And that plus is concatenating the 5, which is a string, to the phrase is prime. And notice there's a little space in there. 5 space is prime. This exercise 3 nicely tells the whole world that whatever number here, 5 is, that it's prime. Go ahead and try it out on your own time. If you plug a 6 in there, I bet it ends up saying 6 is not prime, because 6 has the factors 2 and 3. As crazy as it is, prime number detection helps keeps banks and the military and home security systems and all this stuff safe, because prime numbers help with cybersecurity. And knowing whether they're prime or not with if statements like this is the key. Exercise 4, num equals 70 and answer equals 0. And that's num greater than or equal to 90. That's false. Cross this out. Is 70 greater than 80? False. Cross that out. Is 70 greater than or equal to 70? Yep, because of that equal symbol. This is what happens. Over here, cross the 0 out, make it a 3 because of that line of code. And the letter C prints out on the screen if we were at trinket.io or some other Python editor. Number 5, dividend is that big number, which because I'm allowed to as the teacher, I'm just going to put a bunch of dots there. And 3 and 5, of course, and a 0 goes over here. You need to write it out neatly on your worksheet if this is assigned as homework. Okay, is dividend, when divided by divisor 1, is that big number, 19, whatever, 0, 0, 0, 0, that ends in 5, is it going to have the remainder of 0 when 3 divides into it? There's an old trick. If you add up the non-zero digits, 1 plus 9 plus 5, that adds up to 15. If the number 15, the sum of these digits, itself is evenly divisible by 3, then you know the original number is also evenly divisible by 3, and that means it has a remainder of 0, because that's what it means to be evenly divisible. So all of this is true, even without doing the long division, if you know the tricks. And therefore, we execute whatever code is indented in this if. We ignore the else, but and therefore we put answer equal to 1. Don't forget to circle your final answers, like this and this. Anyway, back to this exercise. Answer was equal to 1, and now we print that dividend, the big number 19005, is evenly divisible by 3. All that prints out, and you should circle all this actually, because all of this is executing because of this true. But wait, we still have more work to do. There's an inner nested if statement that's inside of the outer if statement because of the indentation of Python there. See how that's indented inside of this if else statement. So we have to execute this before we're finished with this video and this worksheet. Dividend, it's that big number again, 19 something 5. Is it evenly divisible by divisor 2? 5. Sure, anything that ends in a 5 is evenly divisible by 5. So this is true. And now answer is equal to 2. And it prints out the additional message that that big number is also evenly divisible by, work from inside the parentheses out. Divisor 1 is 3. 3 times divisor 2, which is 5, simplifies to 15. And we're turning that into a string so that the phrase 1, 9, a bunch of zeros, is evenly divisible by, that all prints out. And then the number 15, because it's actually the digits 1, 5, prints out right next to that. And that is a true fact. If 3 divides into something and 5, then you know that the product of 3 and 5 divide into it. There might be other factors here, but you know that 15 divides into it. Have a great day.